Hello viewers, here is an SMC fan. This is a 12-inch oscillating model, and the model number is TP121A. It's by Shell Electric Manufacturing, made in China. Ooh, made in China. And it draws 0.35 amps. The UL sticker says it's from the 2005, and the other thing says it's from the 2006. Now, this was a Midea made product, as all the SMC fans were at the time for the last 2 or so decades, 2.5 decades, somewhere in that range. I suspect this would have been sold at the Home Depot. This is not an SMC variant that I see very often. I think I've seen these before under the Hampton Bay name. Either this particular variant or something very similar. This one has a number of different characteristics to it that are like other SMC models. The blade appears to be the same shape as the TH12 from the 90s. Meanwhile, the rest of the fan, the base, the controls, and the guard and the badge are more similar to the fans they make today. And there was one model that has been sold at the Home Depot for about over 2 decades now. It used to be sold under the Palm Air name, and now it's sold under, I think it's sold under Hampton Bay. For a while it was just generically sold with no particular brand at all. And that fan is more similar to this one as far as the guard is concerned, and the base setup and the knobs, not knobs, the buttons. Looking at the back of the fan, you have a very odd motor cover, which is not really like any other SMC fan that I know of. Of course, in there it looks exactly like an SMC. So this must have been made of a couple different kinds of plastic, because we have the ring for the guard, which is terribly yellowed, the knob, which is terribly yellowed, and then the pivot mount, which is totally yellowed. And then the rest of the fan is completely fine. It's not yellowed at all. It does have a polarized plug, which I'm going to put into the kilowatt meter. We are currently testing at 120.6 volts. And I'm going to tilt this down a little bit, turn the oscillations off, and we'll start it up on the low, which of course is the first speed. Now this is a very powerful fan for the era of the mid-2000s. I would say this is as powerful, if not more powerful, than the TH12, which I think was one of the better fans at the time. It seems to be running pretty well. Now we'll go to the 2. Not a big increase in speed. Oh, I forgot the power draw. Power draw is 0.28 amps, and on the 2 it is 0.29 amps. So unless you have a problem with the noise level, there's not really much of a reason to put it on low over putting it on medium. It sounds a little odd. It almost sounds like there's something on one of the blades. The high. And that is also the 0.29 amps. So there's really no point in using this on anything other than high unless the noise is bothering you, because it seems to use the same amount of power on all the speeds. The motor seems to be a bit overpowered in relation to the lack of power draw change and There's not much of a difference in the speeds either. It almost sounds like the blade is warped or something. It looks a little weird when I had before I assembled it. The blades, I noticed that they looked a little strange. It's possible there could be some warping going on. Not certain. It's pretty out of balance, and the air is not like, it's not steady. I can feel that there's one blade that's pushing more air than the others. So I think the blade is screwed up to some extent. I don't think it's enough to the point where I wouldn't want to use it, because it's still moving plenty of air, but it's definitely not quite right. And the bearings need to be serviced because it comes to a stop very quickly. So we'll have to service the bearings. Okay, now I will engage the oscillations and we'll do it again. 1. And that's the 0.28 amps again. Seems to oscillate just fine. It's a little slow for how fast the blade is going. The 2. And of course the 3. It moves pretty good air. And off. Yeah, those bearings are definitely going to need some service. One of the things I always thought was kind of interesting with these SMC fans was that you could turn the oscillations off, and if you turn the knob, it would adjust the fan. I can't think of any other fans that do that. So I don't want to take the guard off because it's a hassle, but I want to see if I can show the situation with the blades here. Well, see, they're not bad. Yeah, see it? They're stupid goof. You can see here that they're not bad, you know, but I think they may be ever so slightly starting to warp. What I thought was kind of weird was, and it's easier to see when the thing is off the shaft or outside the guard, but right here along the side of the blade, it's like it's not evenly scooped, but it's like that on each of the blades. So if it's warping very evenly. Let's see if it's out of clock at all. Oh, jeez. Good grief. No wonder there's a problem. Okay, so one of the blades is having a major issue. I think it's this one. Does this one appear to be more warped? Let's see. Yeah, it does. Okay, so that's the issue. This blade here, that's why it sounds weird. That blade right there is kind of warped. Okay. Not too much we can do about that because it's a plastic blade. You know, I don't want to play with heat on this blade because I don't know. I haven't really perfected that or even got it anywhere near close to a decent method with the heat gun. I tried to fix a couple of fans like that and it wasn't working, so I'm not going to try that on this fan until I know how to do it. So Okay, so that figures that out. There is definitely a blade issue. That one blade is warped, and that's why the airflow is not steady coming out of the fan. Geez, that's too bad, because that blade is less pitched. So if that blade was correct, this would probably move even more air.